because like I mentioned last time, Apple supports a lot of different, pre-trained data sets, which are pretty awesome. Okay, so let's put that in place right here, and let's get moving. So all right, welcome back. We are MAPD724 in the winter 2022 semester at Centennial, and it's week 10 of our broadcast and time together. And we're talking about machine learning this week and how that is another set of frameworks, not just one, but many different things together, to kind of combine into something called Core ML. Let's talk about that and see what it is. This week, we're sitting at week 10. Again, your assignment 4 is due this weekend. So that's like this week, by Sunday is when we've made it due. In-class exercise 8, like every week, again, it's also due this weekend. And if I'm not wrong, I think we made in-class exercise 8 due on, we're going to make it due. Now, again, I can make it due on Saturday or I can make it due on Sunday with the other one. It's up to you guys. What do you want me to do? Because I'm going to release it. I want to make sure that you guys are good with it. What are your thoughts? Normally it's due Fridays, but again, Friday doesn't seem to work for you. So I don't want to pressure you. I want to make it so it's good. What day is good for you for in-class exercise 8?
Sunday.
Sunday? One person says Sunday. Anyone else? Okay, sure. So you want it the same time. It'll be due the same time as everything else. I'm okay with that. So let's do that. So we'll say that again, we'll move it to the Sunday, which is the 27th. Okay, that's when it's due. And I think it's pretty straightforward in terms of what is due. We're going to talk about this in a second. And we'll point out, just like last time and every time, when it's happened. So in-class exercises, they don't have an extension. You don't, if you're late on Sunday, it's gone, right? That's how it works. It's not the same as assignments, because they're just supposed to be like just one little piece. It's your practice. It's worth 1% of your final grade every time. And that's when it's all due. So that is in-class exercise 8, due Sunday, this Sunday at midnight. Again, just alongside with everything else that's up right now. Okay, so that's what's happening. So that's alongside with your assignment 4, frameworks 1. Frameworks 2, which is due April 10th. That is the second part of your assignment. And the last part, which is your final presentation, that's going to do it the last week of class, where we do presentations in class. That's what's happening there. All right, so that's where we're sitting. We're sitting at week 10. I7, I could. Let's make I7 also do this Sunday, just so people who haven't had a chance to do it, you have a chance to do it again. I have no problem with that. So let's make it due the 27th. Guys, and let me talk about the reason for my flexibility, because, at the end of the day, what I want you to think about is this, right? This is a grad course, right? You guys, at the end of the day, I trust that you're going to take this opportunity to try things out. It's not just for marks, but also for practice, so you can get better at what you're doing. That's why we're doing it the way we're doing it. It's not meant to kill you or to be oppressive. That's not my way, like, as you know, right? So at the end of the day, you have a chance to practice and get things done. Let's get back to this part. So again, last week we did displaying animations. So very, very simple lab, I think. And all you're doing is just doing the exercise that's online. Similarly, we're doing the same thing this week, is about Core ML. Assignment 2 part 1 has been released and is due on Sunday at midnight. Assignment 2 part 2, right now, that is due. Let's put that into play, right? So part 2 is due, again, it's supposed to be week 12. That's the due date that it's supposed to be. right? But I believe, if I'm not wrong, if we look at the assignments, it's April 10th, right? So what is April 10th? So if we take a look at our time, April is around the corner. It's really bizarre how the semester is rounding out, right? So if we think about this, week 11, 10, week 11, week 12. So it's going to be week 12 right now. That's April 10th. My thinking is I'm going to move it out, right? So instead of assignment 5 being April 10th, I'm thinking about making it, because the final week of class, if I'm not wrong, if we look at April, is, if I'm not very wrong, I believe is the week of the 17th, this week here. And that's when you're doing your live presentations on Wednesday, April 20th. That's when it's due. So my thoughts are, why don't we move our assignment 5 part 2, frameworks part 2, to Sunday the 17th. That's my feeling. And the reason for this is it'll give you a chance, it'll offset some of the stuff that's going on with other courses. And it'll give you an extra week, to do your data persistence and put things together. Are you guys okay with that? Or do you want to do it? Do you want it to be done earlier? It's up to you. Again, I don't want to pressure you. It's there for you to make sure you're okay. Are you guys okay is all I'm asking. So again, I'm pushing it out. I'm not pulling it in. You guys should be okay with that. Check mark if you're okay. How about that? And X if you're not. Okay, some people are saying, yay, okay, good. All right. So yeah, so that's what we'll do. So we'll say frameworks 2 then. Let's change the date way ahead of time. And we'll say that instead of it being, we're what it says here, which doesn't make sense. Again, we'll make it so that it's the 17th. So it's going to be 17th. And just so that we're clear, I'm just going to change all the dates and all that stuff online, just so that we were good. So that'll be the week 13. So the second last week of class is when it's due, and it'll be on the Sunday, obviously, because that's the April 17th. Okay, and that's when the due date is going to be. So the end date will also be the Wednesday, right? So the 20th. So worst case scenario, we can't make it that day. We're going to have to make it on the Tuesday because you need to have everything ready to go and done so you can present. Okay, so that's why it's not supposed to be this late, but I'm pushing it out so that way you have a chance to complete it. And I want to make sure everyone's successful. That's why we've done that. So we moved it out just an extra week. And that means that this is going to be due, if we look through this, so this is due week 13, right? At midnight. We'll say Sunday, April 17th, right? 2022 at midnight. And I'm doing this online, recording this online, so that way you guys are good. So then after that, your final assignment, so which is assignment 2, part 3, which is your final presentation, right? Of your app that you're making, that's due on the last day of class. So due on the very last day of class, which is Wednesday, April 20th. Wow. And that's 2022. And then by class time, because you need to be able to present, right? That's the thing when it's due. So just putting it out there in the video to make sure that everyone is good. So make sure that you know that that's true. Okay, any concerns, questions, or anything else you want to know about this? These are when everything is due, so that we're way ahead of time. We're week 10 now. We have 4 weeks left after this, so 4 classes left after this one in terms of when everything is due. How are we doing with the other courses in terms of your capstone and all that stuff? Okay, let's just do the thumbs up or the check mark, whatever you're looking at. If you're good, if you're not, cash is okay. Thumbs up. All right. The reason why I'm asking is I want to make sure you guys are okay, right? It's not because I'm stressing you or whatever. The idea is that hopefully the other instructors and everything else are guiding you the right way to make sure that you're finished your capstone properly. One thing I mentioned was that you can have, if you're going to do something that's related to your capstone for assignment 2, that's totally fine. Not sure if you guys are doing that or not. Like last time, is there anyone who wants to get feedback early on their assignment 2 part 1 that you're going to show me today? Do you want to show anything? Is anyone interested in showing me anything today? If you are, check mark, please. If you're not, just leave it alone. How about that? Okay, I got no takers on that one, which means either you're not ready or you're not ready to show me. Oh, Ashish, you're ready to show me. Okay, Ashish, I'm going to give you bragging rights because you're the only person that's been doing this so far today. I'm going to stop sharing mine, and I'm hoping that you're going to share yours. Okay, go
Yes,
ahead.
I got the designs. I mean, I have the Figma designs. Shall I share it?
You share whatever you like.
Okay.
I'm always willing to see what you guys got.
Can you see my screen?
I can.
Yep. So I'll run through the design.
You guys love that Figma, that's for sure.
So we have created the design so far, and we are basically creating a restaurant booking app.
Hmm.
We usually we are using the map kit and code location in order to achieve this. So this is a login screen on this. When you log in, there are 3 tabs down. One is to search for the restaurants, one is to see the bookings, and the last one is the profile page.
Awesome.
Let's go to the booking part. So here is where we are going to add the map, and we'll add the markers where they can just we'll use the location to point to the current location of the user, and then they can just move to the map and select any of the restaurants they want to book. So let's say if they click on any restaurants booking, it opens up the reservation page where it shows the details and stuff, all the timings, ratings, contact details, and then they can click on the reserve table. So this screen asks for the basic details, and they can provide the name, number of adults, kids, and here will be a selection for the date and time for the booking. We are going to use that the calendars and the widgets, the default widgets in the iOS for that option.
Awesome.
And then they click on the confirm, so it basically generates a reference number, and we'll try to store this data in the core data, and they can see the bookings from here, the existing bookings. But I think that's pretty much it. Yep.
Okay, so a couple of remarks for me. Just from a design perspective, try and think about. So go back to your your screens there. I love the fact that you can click through with Figma. It's great. If you go to your making your because it's a nice mock-up that you got. Go ahead, go to the next screen. So what you want to do is watch the colors, not this one, but the place where you add in all your booking. The contrast, this is okay. Go ahead. And that's okay. But this part here, you probably want to make it a black color or a darker than a white color. White color, even if it's placeholder graphics, it's too white. It's hard to see, right? So contrast wise, it might not be the right thing to put in. If you're going to include icons the way you've had them, they're pretty small icons, right? You may want to consider making them bigger and giving yourself more margin on the left side than what you have right now in general, just from a balance perspective. They're kind of small if you're going to have them at all, or include them inside, like they should take a portion of the input, one of those two things, if you're going to use them at all. I think it's good that you use them because they give recognition rather than recall. You don't want them to remember, you want them to see it and recognize it, what that is, right? So you can see I like them because it tells you the phone number, the email, like not even looking at what's in there, phone number, email address. It doesn't show, I don't know what the next one is if I was going to look at it, but number of adults, maybe you want to think about the number of people, right? The number of kids, maybe there's something else that you can put in there because you want to be able to, the kids are okay, but the adults, I'm not sure what that is. They'd have to read it. And then the next time they see it, they'll get it, right? So that's pretty cool. The timing is good. That's really good. And the calendar is good. The date and the time, All that stuff is great. Like I said, I think about when you're using it, you want to make it transparent on the back end. Typically, you want to make it so it's like it kind of gels with the entire app. If you don't make it that way, you want to consider thinking about making it a navigation on the left-hand side. So here's something you can do as an option. Make the entire left side of the screen black.
Okay.
So think about this, right? So if you were to color the left side of the screen, not half the screen, just the part where that bar is, almost as if it's a navigation bar on the left-hand side, right?
Mhm.
If you made it black and you made those icons white, it would be a really nice contrast with what you have right there. You can make them thicker. You can make that bar longer, although that the text area would be pushed towards the right-hand side of the screen, right? That's the only thing that would be different. So it wouldn't be as balanced as it is right now. Again, these are just considerations that you can think about. Otherwise, the design that I'm seeing here is really good. I'm really happy with the way it's looking. The other thing is that can you go back to your logo? I think it's like the first page.
Yeah.
So I really like it. I would have loved to see, it's the same thing here for the email and stuff too, by the way. So a different font color. I recommend, again, something like, if you don't want to use black, you can use something like a lighter gray or a slightly darker gray than what you have right there. I think it's good for balance. When it comes to your, the way that your Ds are, I would have loved for the Ds that you have on top of each other to literally be aligned with each other. It'd be nice if the Ds,
Yep.
one D was on top of the other D, if you could do that somehow. And sometimes what it requires is, instead of actually having it typed as a label, you have each of the letters, created inside of another application. So the whole find food would be an image rather than a label. All right. And because it's such a neat idea that you have find and then you have food at the bottom. So, and I think it's very, very simple. And the thing is, you can make it really stylized where the Ds can even be like, I've seen things like where people use their, they start off with find food and then they do a bit of a small animation and the Ds turn into a mouth and the O's turn into eyes. Like they do all kinds of weird stuff like that to make it interesting and funny. Right. So it's really up to you how you want to do it, but balance is really, really important when it comes to a logo. And I know you're not necessarily artists, but think about it from what that looks like. See how much better it would look if the Ds were on top of each other. Try it out and see if you agree with me later on. Okay. But otherwise, in terms of what app it is, I think it's a great idea. Very simple. If you can pull it off, that's awesome. Great job.
Hopefully we should be.
Okay, great. Thank you.
Thank you, Professor.
Yeah, thank you,
problem.
Professor.
Okay, so that was great. Thank you for that, that demo. Is there anyone else that's willing to show me their stuff? I think this is a great opportunity for you guys to kind of share and then get feedback again from anyone else. I think there's some really great stuff here. So great job. Anyone else? Okay, if not, it's okay. Like I'm not gonna, there's no pressure. It's just I was hoping to give you more feedback as early as possible. That's all. So then you know what to do. Okay, so very good. Thank you for that. And let's move on to the topic of today. So the topic of today, again, is you have our core ML that we're talking about today. So really, what we're discussing is we want to create AI. And every time I think about AI, it's not the AI that people think about. When we look at AI, we're like, it's not like Terminator AI, okay? It's not like a living AI with a sentient, mind that's going to take over the world. It's not that kind of AI. And whenever I think of machine learning in general, when I think about it, it's almost as if in my mind, I'm thinking about it like super statistics. That's really what machine learning is these days, okay? More than AI, like a robot that's going to attack you or it's going to talk to you or it's going to give you some suggestions in terms of like your love life. Okay, none of that stuff is happening. It's not going to have feelings right now, and it's not going to have emotions. It's not going to, kind of have its own personality necessarily. And even the personal digital assistants that we have today, things like Amazon's assistant, I'm not going to mention it because I have it right here, as well as Google's assistant and Siri and all this other stuff. all of them use natural language processing, and it's not to the point where they really understand what you're saying. They focus on voice recognition to understand your intent. That's the first part. And then some kind of action. So example would be, hey, let's say, let's ask my little personal digital assistant right here in front of me about the weather. And I'll say something like, Alexa, what's the weather tomorrow?
Tomorrow in Mossington Park, you'll see lots of clouds and can expect a high of 8 degrees Celsius and a low of 2 degrees.
Okay. So what did I ask for? I asked for the weather, right? And it returned back with my intent, where it's trying to figure out my location. So it kind of sits as like, where are they looking for it, right? If I was to specify another location for my personal digital assistant, like, for example, Alexa, what's the temperature in Pakistan tomorrow?
Which city in Pakistan?
Okay, see that? Okay, so what city in Pakistan should I ask for, guys?
Which city in Pakistan?
It's going to keep asking until I tell it exactly the location. Okay, Lahore, no problem. So Lahore.
Right now, in Lahore, Pakistan, it's 24 degrees Celsius. Today, expect a high of 32 degrees.
32 degrees. It's crazy. I can't believe how hot it is. I wish it was hot like that here, man. Right? That would be awesome. Okay. So why does it do it? What it does is, again, it listens for what you're asking, right? Whether, where, and when. Those are the things that you're asking for. So I want the weather in a location. When do I want it for? Okay. That's the kind of stuff that you can do. And you can ask for other things like that as well. But does it make it intelligent? No, it does not. It just is literally like a hands-free way of getting some information. That's what it can do. It can play music for you. It can do simple tasks. It can activate things. It can deactivate things. It can do all kinds of stuff that is interesting, but it doesn't make it intelligent. It's not, artificial intelligence necessarily. It's really more like knowledge enhancement. I want to know something and I want to get it without touching anything. I don't need a keyboard or a mouse. I don't even need the screen. I can just give my voice commands and it's going to give me something back, right? But it's not like Tony Stark's assistant, okay? It's not like I can sit there and say, Jarvis, as an example, calculate the telemetry of my missile and fire. I can't do that kind of stuff. It's not going to happen, right? And it's not going to give me advice about whether I'm drinking too much or I haven't exercised enough or whatever it's going to do. It's not that kind of AI. And people get confused about that a lot, okay? Because they think about AI as artificial intelligence, like the sentience, that singularity that's going to destroy the world. It's not like that, okay? So what we want to do is, like what it says here, is mimic intelligence. We want to kind of make it so that it feels like, it's somewhat intelligence. It's going to kind of fool us or create a scenario where we believe that, there's some kind of intelligence in the back end, okay? So again, things like chess, and as an example, or if we're going to make gameplay AI, there are some things that we can use for gameplay AI that are very interesting. So for example, let's suppose I want to make an AI agent, okay, something like that, where it's going to find the player on the screen, okay? Now we can use algorithms to mimic that ability for it to find you on the screen. Example would be pathfinding algorithms like A-star pathfinding or Dijkstra's algorithm. We can use those things. We might use a division scheme, like where we divide the game into a grid or nodes or something like that. And once we've divided the game, something that we're looking at, we've subdivided our world into some kind of division scheme that makes sense. Then we can use an algorithm to go from one path node to the next until it finds the shortest path, a lot of times, to the player, right? We can also, in games, do other things like, for example, gameplay AI, which is try and find the best solution, right, based on the world state. That's something else. We can have the AI do something called deep learning or reinforcement learning, where it doesn't have any supervision whatsoever, and it learns from the world on its own. That is a different type of AI that is much more advanced. But each of these things, again, is not true intelligence. It mimics intelligence by getting data and using algorithms so that it steps through very quickly and creates it can make decisions based on its input. Whatever you give it is what it's going to make decisions. A lot of times it's, to be honest with you, garbage in, garbage out. If you give it bad data, it's going to have a bad decision. Okay. So example would be, Alexa, what's the weather on the moon tomorrow?
According to an Alexa Answers contributor, the moon does not have an atmosphere to generate weather.
There you go.
Temperatures when the sun up can be over 200 degrees. When the sun is down, it can be negative 200.
There you go. So it actually has that answer. But sometimes you might get an answer that really surprises you. That's like completely whack. Like it's not what you're asking for at all. So it's kind of interesting. So limited domains is what we're talking about. And so AI focus on machine learning, where we can do things like the ability for us to take a look and track and do a little bit of prediction with the data that we have. A lot of that is when it comes to data is how much data we're analyzing and our analysis tools and how we're going to get there. So again, it's not that they're creating an intelligence. What they're doing is we're using machine learning, right, to figure out or to predict, what the possibilities are based on the data set that we're looking at. Okay, I'll try that, Ishtiaq. Alexa, how many trees are on the moon?
Here's something I found on the web. According to arlingtonmagazine.com, it's estimated that some 70 to 90 of the original so-called moon trees remain.
There you go. 70 to 90, whatever that means. I don't know if what, I don't even know.
70 plus 90 equals 160.
That's right. You can be a good calculator. Thank you very much. But that's not what we asked. Alexa, what are moon trees? I don't even know what that is.
According to Wikipedia, moon trees are trees grown from 500 seeds taken into orbit around the moon by Stuart Roosa, the command module pilot on the Apollo 14 mission in 1971.
That's pretty awesome. So this is the stuff that it
idea was
does.
proposed to Roosa, who had been a smoke jumper, by Ed Cliff, then the chief of the United States Forest Service. Seeds for the experiment were chosen from 5 species of tree: loblolly pine, sycamore, sweet gum, redwood, and Douglas fir.
Thank you. That's a lot of detail, right? So again,
I'm not quite sure how to help you with that.
good. It's okay. You don't have to help me. So again, one thing that we want to think about is we can, sometimes there's such a large data set, and this is where machine learning can really help us. It's a large data set, and for you to sort it by hand or to use something like an Excel spreadsheet or even SPSS or something else like that, when you want to do your your analysis, is very difficult, right? And so what you want to do is you want to use machine learning algorithms to help you with that. And so let's think about what that does, right? So we have some we create generic algorithms to train our data sets, and that's what we typically do, right? And a lot of times the generic algorithm that we use, a lot of times we can use, for example, a decision tree algorithm. A decision tree algorithm basically has, it's usually a balanced decision tree, and it goes either right or left, true or false. And what it does is it takes numbers, a range, and it uses the, kind of quickly sorts through and kind of decides based on the data set for each piece of data, right? As an example, it sorts it into the right order, and then it creates, kind of a decision on whether it's going to be in the data or outside the data. Does it make sense? And it creates almost like a regression pattern, for the data set that you're using. So trees are definitely things that they use, okay, which is kind of interesting. So training an algorithm is very interesting, because if you have a trained algorithm, then it can, what you're doing is there's 2 types of learning. There's supervised learning and unsupervised learning. And with supervised learning, you're basically saying, this is good, this is bad. And when you start training an algorithm, you're basically telling it that, the decisions it's making, for the predictions that it's holding, especially if it's inside of a band of possibilities, we see a trend as an example, that these are good things. When you pre-train a piece of data like that, you can use it again and again and again. And there's a lot of trained data sets out there that are pretty good. One thing that we don't want to do is this is a problem that can happen with data sets is that you can overfit your data. And overfitting is an issue because it's like very specific to that one piece of data, that one data set, but not for the algorithm won't work for other data sets or other scenarios. And that's also very, very bad, right? Because it's almost like when you overfit, you're squeezing in the possibilities or reducing the, your answer is always going to be the same, which is not really prediction, okay? Or it might not work. The answer may not work, might not provide any kind of reasonable data at all. So, so there's a couple of problems that machine learning solve, and one of them is image recognition. So again, we can train an algorithm to recognize a dog or a boat in a picture, as an example. But eventually what we want to be able to do is recognize dogs and boats that it's never seen before. But why? Because dogs and boats have certain keyframes or certain anchors, if you will, kind of key points, that it can focus on to say, hey, this shape that I'm seeing here, right? It's most likely a dog, right? Or it's most likely, there's a high confidence. That's what it'll tell you. There's a high confidence that it's a boat or a plane or a person or whatever that it's recognizing. And it's based on the data set that it's been fed, where it has a data set and you say, this one is a person. Here are the data points that related to it. You can actually train it very, very specifically to say, I'm looking for a person, might have a bunch of data points, for example, on the eyes or on the nose or on the mouth or whatever, in a certain configuration at a certain distance. And these kinds of data points is what image recognition does. It takes a look at those and says, okay, I've seen a very similar configuration, plus or minus this many percent, that error rate, because people's faces are different sizes. But this is a person. It can recognize if it's a person or not with a high confidence, actually. So again, things like spam filters, right, that can identify spam email because where it's coming from, email that you've never seen before, that's coming from an unidentified source or an untrusted source, with certain keywords that are used in the email where they're trying to sell you something or they're trying to get you to do something. The machine learning is great at identifying those things. Really, really great, right? But you train the data every time you make it, you block. If you block a piece of email every single time, worldwide, we help train the spam data set, right? So what's happening is everyone who's clicking on block or, this is spam or whatever, you're training it. Sometimes you're training it in the wrong way because it's basically saying that, well, this kind of email that you're getting, maybe it's from your gas company. You don't want to get email from your gas company. You say that's spam, but it's not, right? So that's also what it can do for you. If it'll kind of select the wrong things based on how you train it, right? So again, machine learning in general involves 3 basic steps: developing and writing algorithms, training the algorithm with large amounts of data, a huge data set a lot of times, and using that trained algorithm, and we call them a machine learning model, right, in order for you to apply it to another data set, okay, which is similar data, but another whole other data set from some other time, okay? So it's kind of an interesting scenario. So again, like it says here, creating algorithms can be super difficult, and it takes a lot of time, and a lot of times it needs patience and time and supervision in order for you to make that algorithm really looks nice. And what's happened is Apple has done that a lot for us already. There's a bunch of them that we can look at. So again, there are 2 separate sources for machine learning models that we can use: core ML models that are made by Apple, and non-core ML models, which you can also use, right? But again, it's something that's outside of the framework, which is pretty cool, right? So again, core ML models, they've converted a lot of popular machine learning models into core ML models, which is pretty cool. What they've started to think about is, well, you know what? Users probably need some kind of image recognition stuff. They want to be able to detect, what type of plant they're looking at, what type of dog that I'm looking at. Is this a dog versus a cat or whatever? So they want to do some image recognition and isolation. You want to kind of basically, kind of boil it down to what you're looking at, right? And a lot of times our phones, especially Apple iPhones, are very powerful. They have especially nowadays with the latest A15 Bionic chip that's on an iPhone 13 or even the new iPhone SE that's come out, very powerful, very quick, and they can deal with, they have almost like an ML, co-processor that helps you with machine learning. And why would they make that happen? Because they want your phone to be able to help you as much as possible to do things like, sharpen an image, all those kind of things, any kind of compression, decompression algorithms, those kind of things. We can use machine learning for a lot of that stuff. So that's very, very interesting. And so making your app appear smarter. Basically, you can train your app if you're something that you're using all the time to make recommendations to you. For example, if you're shopping on Amazon, a lot of times, Amazon, the site will make recommendations based on, what you've looked at. Same thing with Netflix. Netflix uses machine learning to make recommendations based on the stuff that and how close it is a match to the stuff you're watching. Same thing with Prime Video, or whatever. It's all based on your patterns, right? Hey, speak normally to a phone and you'll start getting a lot of recommendations, because if you have Facebook or if you have Twitter or if you have Instagram or anything like that, what's going to happen is the stuff that you're talking about, your phone is always listening and it's training your marketing. So it's going to be directed marketing right at you based on your interests. A lot of times they can even use things like, without you knowing, your facial expressions to kind of understand if you're happy or sad at the thing that you're looking at, bored or interested, and those kind of expressions are things that they're taking from you without asking you at all. As soon as you turn on the app and you look happy or bored or sad or whatever it's going to be, it automatically can detect your mood, and it can kind of select images and things that it's going to kind of display to you based on how you're looking, what you're saying, what you're and all that kind of stuff, and what other things you're searching for. Scary stuff. That's the scary stuff that Facebook and Instagram, same company, use against you. So again, basically the best way to do it is to let's go to developer.apple machine learning. And we did this last time because I was talking about machine learning as a framework that you can use. And this is pretty cool. It talks about different APIs. So here's natural language processing. That's like what we just did when we asked my little assistant here, I'm not going to say the name again, is going to activate. Hey, what's the weather? That's natural language processing. Natural language processing has two parts. It could be voice recognition, which is also part of it. That's speech. That's this part. And then it's tied into the back end, which is natural language processing. And what happens is, again, it takes those three things. It recognizes what you've said. So what did you speak? That's the speech recognition part. Ties it into the back end, which is what is the intent? Who is speaking, if possible. My assistant knows who I am because they asked me to train it, to tell them it's Tom. It's not, my son or my wife or something else. It's whoever I am. So they know my preferences. That's one thing that it is. Example, if I ask for something like, what's the news? And if I've already asked for what's the news, it's going to recognize who I am and says, okay, here are the updates for the news that you haven't heard today, kind of thing. It's going to know those kind of things. So that's all about the natural language processing piece, where it can take it's going to convert speech to text, take that text and use it on the back end to recognize your intent and return data back out. When it returns data back out, returns it into text and then speaks it out to you, right? So that you can hear it, right? So which is kind of interesting. All right, so that is interesting as well. Sound is good because what you can use with the sound part is really neat. It can do sound analysis. Shazam is a good example of doing sound analysis with machine learning. You can sing a song or you can play a short snippet of a song to Shazam and it'll tell you what the song is with really good certainty, because it can recognize bits of a song and kind of tell you what that song is, whatever. And that's using a great example of machine learning where it uses sound analysis, right? NVIDIA uses machine learning as well. Here's something where it uses. So I have NVIDIA Broadcast. Okay, I'm not sure if you guys have this on your PC. It's only available for RTX series GPUs, right? So as an example. And what it does noise removal. It does all kinds of other stuff. So if you hear any kind of crackling or popping or anything like that, it cleans up the data stream so you get better audio, right? So I use this a lot. It also cleans up the stuff that comes in from you guys. So it cleans up your sounds, as well as if I want to, I can also do things like I can remove my background if I really want to as well. I'm not using it for this right now, but I could. I'm using another algorithm for that altogether. But NVIDIA Broadcast is a great example of a machine learning algorithm that uses the GPU to have really performant, near real time, kind of machine learning that allows you to clean up sounds and all those kind of stuff, which is kind of neat. So that's sound analysis, which is neat. Again, another framework when it comes to kind of, removing sounds and all that stuff. But from a core ML perspective, it's really neat what you can do. And like we talked about this last time, you have different kinds of models, and you can see that they have a couple of additional new models. One of them is video, another one is an image model for a hand pose classification or a hand action classification. These are great, the fact that they have these models in place. And again, you can look at your SDKs and betas, as well as your models that you can take a look at as well. Let's take a look at those models. It's up on the top here. And you can see that these are all the images that we talked about last time. So they have things like, image classifiers, and classifiers are ways of, kind of looking at weight points on an image, right? As an example, to try and kind of detect with certainty what kind of object that we're looking at. Okay, so here's the different models, and you can use these models when it comes to machine learning, which is kind of cool. PoseNet, that's awesome that it has that it actually can look at, if I can use machine learning to detect where your skeleton is. Again, I can't wait for this to happen more. That means it's going to remove things like performance capture in video games, and even in, where we can replace, kind of an object with a mesh, right, that's been artificially created, which is pretty awesome. So that's great that it does that kind of stuff. Text recognition is awesome. There's some great algorithms for that. I'm not sure if you've tried using Google Translate as an example when you're at a restaurant. And if you ever try that now, it's actually active. You can go there and use Google Translate, where you can look at a menu and it'll translate the text into whatever language you want it to. And it's really great at what it does. Again, I mean, to some degree, right? And I say to some degree because depending on the language and the glyphs that are being used, it'd be more challenging. A good example of that is if I went to a Greek restaurant and it has Greek letters. Greek letters are very different than English letters, depending on some of them anyway. And so to try and figure out what it's saying and then convert it to Greek and back out to English is really challenging, and it does it almost in near real time. I used the Google Translate when I was in Colombia in 2018, and I was looking at a menu, and I don't speak Spanish, so I was looking down and I was looking at the menu and it was translating for me, and I knew with some certainty what I was looking at. Okay, it wasn't accurate, but I got the idea, right? And that was good enough for me to have what we like to call intelligence augmentation, which is a better thing than machine learning and artificial intelligence, right? In many ways. All right, so it's kind of really cool stuff. And I think that there's a lot of models on here that you can use, right for your applications, which is really cool. All right, so that is the Core ML, and it talks about how to find a Core ML model. There's a lot of other Core ML tools that are out there for you. Whether you want to use, these are traditional Core ML tool or tools that are out there that support models. For example, scikit-learn, which is something you can do with Python. TensorFlow, which is available on all platforms. C++, it's available on the web. It's available on Python and a bunch of other languages, which is really cool. And a bunch of them can kind of tie into anything that you're using already. So things that are outside of the Core ML framework, you can use to tie into what you're doing here. So if you wanted to use another data set that you're familiar with, even if it's not mentioned in the ones we saw, you can still do that, which is pretty cool. So on that, I have to mention that Python is a big part of Core ML. And, a lot of times, I'm hoping that you guys all have used Python before. Has anyone not used Python? If you haven't used Python, X, please. Wow, Akash, you need to figure that out. And same thing with Carlos. I think it's an amazing little language to learn. I think it's a quick learn for you guys. Walter says rarely, but the great thing about Python is it's really in many ways designed now, or machine learning is designed around that language. Okay. One thing I like about Python is its simplicity. And another thing I don't like about Python is the same thing that a lot of people don't like about JavaScript, which is its simplicity. It doesn't have the same structure. It's loosely typed many times as well. And so, so that kind of stuff, if it's very Pythonic, people don't like it. And the reason for this is because it's like, hey, I wouldn't mind if it was more structured and it gave it more, had more data types and so on. It does have data types, but some of the things that you can do in Python very quickly are made for, not necessarily for programmers. They're made for non-programmers. They're made for scientists, especially data scientists. So it's kind of neat that it is the way it is, especially Python 3, the latest version, which is pretty cool. So, so again, you need to look at what the machine learning model does and how large its file is. And a lot of times, if it's a very big file, it can influence what your performance is and how much space it takes on your device. Again, one thing you're going to have to do is when you use a machine learning model on the device itself, it does take up memory. It is what it is. For every, it's part of the app that you're creating. All right, so that's something that you're going to use. So this is the image classifier that I talked about. Okay. So, so again, when it comes to image recognition, as an example, right, you can download for this in-class exercise, what it's asking you to do is download both models, right? So download both the MobileNet and SqueezeNet models from online, all right, from the link above. And then what you want to do is you want to visit any search engine and look for images of any object, such as a car, a dog, a computer, or a bird, and download those things. And what you want to be able to do is, as you step through, it talks about how to use SqueezeNet and MobileNet in order for you to identify the image that you've downloaded. So very, very cool. It also steps you through this app, which is the image recognition app. There's a couple apps that you can do here. And this is the image recognition application. So if here's something for this in-class exercise, you can do any of the parts of that's here that you want. You don't have to do, if there's more than one app that's listed on the PowerPoint or up online, you only have to do one of them. Okay, it's up to you. But it walks you through how to import it, how to use it, how to create your application, which is pretty straightforward. And a good example of it is I use Cars for making this little application, which is kind of interesting. And it kind of evaluated the type of car it was and how to make use of the application. Okay, so that's what this whole thing does. And then you create a simple storyboard. And for this one, this UI image view, it's going to take the image that you've downloaded, and it's going to try to identify what it is, if it's a car, or what it's going to do based on the image classifier that you downloaded, which is pretty cool. So please take a look. This is what you need to do for this in-class exercise. If you build the image recognition app, it's pretty cool. And I don't think it's that difficult to do if you follow along. It's all the code is up online on the course shell. And I think it's fun little exercise to do. And take a look at what it did for me. When I did this app, it says images, a beach wagon, station wagon, estate car, beach wagon, station wagon with confidence. And it gives you some kind of confidence that looks like 30%, right? So it's like, I'm pretty sure this is a wagon. It's not a wagon. So it got it wrong, right? Which is kind of interesting, but it tried. And it's interesting what it was looking like for a wagon. It's the shape of the car and the angle that I got it at, right? So if you try different images, you'll see the ones that and you have to also understand how they're trained. You can understand how this thing works. So it's very interesting. Again, you can try modifying your project by adding different image files containing cars, trees, horses, airplanes, whatever, and it'll start trying to recognize what they are. Okay, so that is your requirement for this week. Your in-class exercise 8 for this week, which is due Sunday at midnight. Okay, a nice chance to check out machine learning, how it works, put a simple app together and use a trained model with only a few things when it comes to using your image request handler, right? And, to use your core ML to kind of, to try and identify what it is with the model that you're using. Okay? So that's what I want you guys to do. All right, and online, it has the same information. So if you actually go up online, what I've done is I've kind of stepped through it with you, but what I'd like you to do is take a look at the image recognition application. I think it's a good one to kind of put together, and it steps you through, just like I've done right now, each of the steps to do the image recognition application so you can submit it for your in-class exercise. Okay. Questions around this before we go? Again, this is your time. I recommend doing it right now. Take the time today, with the time that you have, because you have until 10:30 tonight. That's the time that you booked. Create the application and submit your in-class exercise. I think it's a great little application, and you can play around with it. It's fun. It's actually kind of fun to do, and you can download other things that are out there as well. Questions around the stuff that I've asked you to do for today and for this week? All right, guys, that's it for me today. I'm hoping that you're going to go away and do that thing, practice. I think it's a great opportunity for you to do that. We are 4, but the group size is 5. Okay, let me come back to you in a second. Let me stop recording now, and then I'll come back to questions around the stuff that's happening for your assignments.